And there is a key loophole to my above argument. This argument, right, assumes that the lower terms in the series, right, just give me some number, right, which then I can build this exponential growth upon. However, what if some term in the series, we must have some term, p sub n plus 1, for n greater than or equal to 0, must be 0. If I have a term like this, where at some point in the sequence, my coefficients p go to 0, that would then ensure, from my recursion relation, right, that then all of the future terms in the series are 0, and that's the one way out. That would mean b is 0. And if b is 0, I don't have this exponential growth, and I can have a solution. So this is the only way out. I need to find special values of alpha that make one of the terms in the sequence go to 0. Now, how can that happen? Thus, well, let's look at the recursion relation. The recursion relation, not the approximate one, but the actual one, has this factor in the numerator. I therefore need this factor to be 0 to give me a bound state. This is what I need. This must equal 0. That's what the boundary condition is actually telling me. So let's write down that relation and see what it actually is telling us. So I need alpha times n plus L plus 1 minus 1 equals 0 for some n greater than or equal to 0. This is the key relation. And if we can show, right, that alpha from this must be 1 over a natural number, we have done it, and we have solved for the structure of the atom. So let's solve this for alpha. So alpha is going to equal, we put 1 on the other side of the equation. We divide through by our factor, n plus L plus 1. And n and L, right, this is looking very good. N and L have very special properties. They are non-negative integers, right? So these are integers, and they are both greater than or equal to 0. So what that means is that what I have in my denominator is also an integer, but since these start at 0, and I'm adding 1, it's 1 over some integer, capital N, where n is a natural number. It starts counting from 1 and goes upwards like so. So, if you think about it, right, that's it. We've done it, right? The theory actually gives us, through the boundary condition, exactly the condition we were looking for. So alpha is an inverse natural number, and therefore, from the very beginning, the energy is minus 1/2 times an inverse natural number squared, which are precisely the experimental results. And we've taken the course full circle, and we've now solved for the structure of the atom.